Hi and welcome to my channel. Today I have brought to you a new topic. We are going to start learning Docker. Till now, we have learned Terraform and I hope you are practicing it and doing good with Terraform. In this video we will run a popular, free, lightweight container and explore the basics of how containers work, how the Docker engine executes and isolates containers from each other. If you already have experience running containers and basic Docker commands, you can probably skip this intro exercise. Concepts we are going to cover in this exercise are Docker engine, containers and images, image registries and Docker Hub, and container isolation. Let's start. First, running your first container. It's time to get your hands dirty. As with all things technical, a Hello World app is a good place to start. To start a container, you can run below commands. Docker container, run Hello World. That's it. Your first container. The Hello World container output tells you a bit about what just happened. Essentially, the Docker engine running in your terminal tried to find an image named Hello World. Since you just got started, there are no images stored locally, unable to find image, so Docker engine goes to its default Docker registry, which is Docker Hub, to look for an image named Hello World. It finds the image there, pulls it down, and then runs it in a container. And Hello World's only function is to output the text you see in your terminal, after which the container exits. If you are familiar with VMs, you may be thinking this is pretty much just like running a virtual machine, except with a central repository of VM images. And in this simple example, that is basically true. But as you go through these exercises, you will start to see important ways that Docker and containers differ from VMs. For now, the simple explanation is this. The VM is a hardware abstraction. It takes physical CPUs and RAM from a host and divides and shares it across several smaller virtual machines. There is an OS and application running inside the VM, but the virtualization software usually has no real knowledge of that. The container is an application abstraction. The focus is really on the OS and the application, and not so much the hardware abstraction. Many customers actually use both VMs and containers today in their environments and, in fact, may run containers inside of VMs. Now, Docker images. In this tutorial, we are going to run an Alpine Linux container. Alpine is a lightweight Linux distribution, so it is quick to pull down and run, making it a popular starting point for many other images. To get started, let's run the following in our terminal. Docker image, pull Alpine. The pull command fetches the Alpine image from the Docker registry and saves it in our system. In this case, the registry is Docker Hub. You can change the registry, we will see that in later tutorial. You can use the Docker image command to see a list of all images on your system. Run Docker image ls or simply run Docker images. It will show list of all images present in system. Docker containers are created from images. Let's see how to create Docker containers. Docker container run. Let's now run a Docker container based on this image. To do that, we are going to use the Docker container run command. Docker container run alpine ls-l or docker run alpine ls later. While the output of the ls command may not be all that exciting, behind the scenes quite a few things just took place. When you call run, the Docker client finds the image, Alpine in this case, creates the container, and then runs a command in that container. When you run Docker container run Alpine, you provided a command, ls-l, so Docker executed this command inside the container for which you saw the directory listing. After the ls command finished, the container shut down. The fact that the container exited after running our command is important, as you will start to see. Let's try something more exciting. Type in the following. Docker run Alpine echo hello from Alpine. And you should get the following output. Hello from Alpine. In this case, the Docker client run the echo command inside our Alpine container and then exited. If you noticed, all of that happened pretty quickly and again our container exited. As you will see in a few more steps, the echo command ran in a separate container instance. Imagine booting up a virtual machine, running a command and then killing it. It would take a minute or two just to boot the VM before running the command. The VM has to emulate a full hardware stack, boot an operating system, and then launch your app. It's a virtualized hardware environment. Docker containers function at the application layer, so they skip most of the steps VMs require and just run what is required for the app. Now you know why they say containers are fast. Let's try another command. Docker run alpine/bin/sh. Wait, nothing happened. Is that a bug? No. In fact, something did happen. You started a third instance of the Alpine container, and it ran the command bin/sh and then exited. You did not supply any additional commands to bin/sh, so it just launched the shell, exited the shell, and then stopped the container. What you might have expected was an interactive shell, where you could type some commands. Docker has a facility for that, by adding a flag to run the container in an interactive terminal. Let's check it out. Type the following. Docker run -it alpine/bin/sh. You are now inside the container running a Linux shell, and you can try out a few commands like lsl, uname and others. The /bin/sh is another type of shell available in the Alpine image. Once the container launches and you are at the container's command prompt, type the following commands. Echo hello world. Output on screen is hello world. Now, run echo hello world, redirecting the output to hello.txt. The output is stored under hello.txt file. ls. File is present there. Check the file contents. Add hello.txt. The first echo command creates a file called hello.txt with the words hello world inside it. The second command gives you a directory listing of the files and should show your newly created hello.txt file. Now type exit to leave this container. To see how the isolation works, run the following cmd. Docker run alpine ls. It is the same ls command we used inside the container's interactive ash shell, but this time, did you notice that your hello.txt file is missing? That's isolation. Your command ran in a new and separate instance, even though it is based on the same image. The second instance has no way of interacting with the first instance because the Docker engine keeps them separated, and we have not set up any extra parameters that would enable these two instances to interact. In everyday work, Docker users take advantage of this feature, not only for security, but to test the effects of making application changes. Isolation allows users to quickly create separate, isolated test copies of an application or service and have them run side by side without interfering with one another. In fact, there is a whole lifecycle where users take their changes and move them up to production using this basic concept and the built-in capabilities of Docker Enterprise. We will explore more of that in later tutorials. Right now, the obvious question is, how do I get back to the container that has my hello.txt file? Check the running containers. Docker container, ls-a, or docker ps-a. Graphically, this is what happened on our Docker engine. The container in which we created the hello.txt file is the same one where we used the /bin/sh shell, which we can see listed in the command column. The container ID number from the first column uniquely identifies that particular container instance. You can check the first column of the output. We can use a slightly different command to tell Docker to run this specific container instance. Try typing docker container start and container ID. Instead of using the full container ID, you can use just the first few characters, as long as they are enough to uniquely ID a container. So we could simply use first few characters to identify the container instance in the example above, since no other containers in this list start with these characters. Now use the docker ps command again to list the running containers. Notice this time that our container instance is still running. We use the ash shell this time, so that rather than simply exiting the way /bin/sh did earlier, ash waits for a command into the container to run by using the exec command as follows. Docker container exec, then container ID and ls. This time we get a directory listing and it shows our hello.txt file because we used the container instance where we created that file. Now you are starting to see some of the important concepts of containers. In the next tutorial we will start to see how you can create your own Docker images and how to use a Docker file to standardize images such that you can create larger, more complex images in a simple, automated manner. Terminology. In the last section, you saw a lot of Docker-specific jargon which might be confusing to some. So before you go further, let's clarify some terminology that is used frequently in the Docker ecosystem. Images. The file system and configuration of our application which are used to create containers. To find out more about a Docker image, run docker image inspect alpine. In the demo above, you use the docker image pull command to download the alpine image. When you executed the command docker container run hello world, it also did a Docker image pull behind the scenes to download the hello world image. Containers. Running instances of Docker images, containers run the actual applications. The container includes an application and all of its dependencies. It shares the kernel with other containers and runs as an isolated process in user space on the host OS. You created a container using Docker run, which you did using the Alpine image that you downloaded. The list of running containers can be seen using the docker container ls command. Docker daemon. The background service running on the host that manages building, running and distributing Docker containers. Docker client. The command line tool that allows the user to interact with the Docker daemon. Docker hub. Store is, among other things, a registry of Docker images. You can think of the registry as a directory of all available Docker images. You'll be using this later in this tutorial. Okay, so that's it for this tutorial. Next we will be doing more with Docker images. See ya in next video.